Today we're looking at the pink page of notes that you picked up today, Geometry Trig Notes. We're talking about the trigonometric functions in geometry. And all this means to us is that if we have right triangles, we already know that we have similar figures if we have like a 45-45-90 triangle or a 30-60-90 triangle, and no matter how big the sides are, those relationships always work. Well, we're going to find out today that even if we have different measures for right triangles, if they have the same angles so that they are similar to each other, the different ratios that we have are going to hold constant. They'll change depending on the measure of the angle, and that's what we're going to use this trigonometry for. So the first thing to note that whenever we're using trigonometric functions in geometry is to make sure that the mode of our calculator is in degrees, not radians. What that means is when I turn my calculator on, and I may have used it in the past, or someone may have cleared the memory of the calculator by typing in the second plus 712, but whenever the calculator is normally used and it defaults to its normal settings, the mode is not in degrees. So I always have to make sure that I'm changing it. If you clear the memory, you're going to always have to go back and change this. The mode button of my calculator is right here next to the blue second button. So if I hit the mode button, it comes up with all these different things that are highlighted. That's what my normal standard default is. Note that the third one down between normal float comes to radian. So the default setting of my calculator is in radians. I want to make sure it's over in degrees. So you're going to go down to radians, over to degrees, and hit enter. So now degrees is the one that's highlighted on your calculator. Now whenever you type in angles, they're going to give you degrees, and you'll be able to use your trig functions. To get back to the main home screen of your calculator, you need to quit. Notice that quit is in blue above the mode button. So if you type second mode, it quits you and goes back to that home screen of your calculator. We're going to be using the trig functions on our calculator. And notice that those buttons are located: sine, cosine, tangent. The dark buttons, kind of sort of in the middle of the calculator, those are the functions that we're going to be talking about. Those are the ones that we're going to be touching in our calculator when we're working some of these problems later today. Our trig functions are basically ratios, and they're ratios of different sides of our right triangle. And in order to remember which function to use, whether you're going to use your sine, cosine, or tangent, you have the battle cry that geometry students worldwide have always used, and that is SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. We're going to use that SOHCAHTOA to set up an equation based on the lengths I'm given before I try to solve the problem, because I won't know whether I need to multiply or divide to get the answer until I set up a proportion using my SOHCAHTOA. This is how SOHCAHTOA works. The first function we come to is that sine function. So if I have a right triangle and I'm thinking about that SOHCAHTOA, the SOH part stands for my S equals O divided by H. What does that mean? It means that the sine of my angle is equal to the opposite side over the hypotenuse, SOH. So that always helps me remember that SOHCAHTOA, that the sine of an angle is the opposite side divided by the hypotenuse. So if I were looking for the sine of angle A, I would look at the opposite side, BC, divided by the hypotenuse, AB, and I would get that fraction or ratio. If I were looking for the sine of angle B, I would take the opposite side, AC, over the hypotenuse, AB, to get that ratio. So it's just a ratio of sides. It can be expressed as a fraction or a decimal. The next trig function that we use is the cosine function. That SOHCAHTOA, the CAH, stands for that the cosine, the C, is equal to the A over H. That helps us remember that the cosine of the angle is equal to the adjacent side divided by the hypotenuse. Cosine equals adjacent over hypotenuse. So if I'm looking for the ratio of the cosine of angle A, it will be the adjacent side, the side next to it, AC, over my hypotenuse AB. If I want the cosine of angle B, it'll be the adjacent side, the one next to it, the BC, over my hypotenuse AB. That's my Ka part. SOHCAHTOA, Ka. C-A-H. The last trig function that we're going to take a look at is the tangent function. If I'm looking at that SOHCAHTOA, the TOA part is my tangent. It stands for tangent equals the opposite over the adjacent. That helps us to remember that the tangent of an angle is equal to the opposite side divided by the adjacent side. So tangent, opposite over adjacent, TOA. If I want the tangent of angle A, I'm looking at that opposite side, BC, over the adjacent side, AC. Notice there's no hypotenuse in my tangent function. If I want the tangent of angle B, I'm looking for the opposite side, AC, over the adjacent side, BC, for my ratio for my tangent function. So let's take a look at triangles and what we're looking at with the different sides of a triangle. So go to your other pink page of notes that you picked up today with our trigonometry vocabulary. A trigonometric ratio is just a ratio of two sides of a right triangle. We talk about the legs are one of the two sides that form the right angle. So leg 1, leg 2, they form the right angle. We talk about the hypotenuse being the side of the triangle opposite the right angle. So if I'm looking at a triangle, like triangle ABC, I notice that B is my right angle, the legs are BC and AB, and my hypotenuse is AC. So if I'm wanting to look at angle A, and I want the leg that's opposite to angle A, across from, opposite from, that will be leg BC. It's like covering up the A and seeing what's across from it. If I want the leg opposite to angle C, covering up the C, seeing what's across from it, I'm left with leg AB. If I wanted to know what's adjacent to A, that means the one that's touching angle A, the leg that's touching is leg AB. And if I'm looking for the leg adjacent to angle C, the one that's touching that angle, it's going to be this leg CB or BC. If I look at the next triangle, it's actually triangle XYZ, so there's a typo there. And I'm looking at angle Y. I want to know the leg that's opposite angle Y. So if I cover up the Y, what I'm left with is the leg from X to Z. If I want the leg opposite to angle Z, if I cover up that Z, I'm left with leg XY. If I want to know the leg adjacent to angle Y, the one that it's part of, that's going to be my leg XY. And if I want to know the leg that's adjacent to angle Z, the one it's part of, that's going to be leg XZ.